In this video, we are going to discuss about graph traversal algorithm called breadth first search or BFS for short. Now, given a source vertex S, BFS will systematically explore the edges of graph to discover every vertex reachable from S. Now, let's see how this is done. Breadth first search expands the frontier between discovered and undiscovered vertices uniformly across the breadth of the frontier. That is, the algorithm discovers all the vertices at distance k from the source before discovering any vertices at distance k plus 1 from source. Now consider this diagram. Here we consider source vertex to be A. BFS algorithm will visit node B, C, D before visiting any of other vertices. Here we can consider the distance of A vertex as 0. If so, A's adjacent vertices, which means B, C, D, is at distance of 1 and all other vertices are at distance 2. Alright, let's now look at the pseudocode for breadth first search algorithm and try to understand how it works. Now in the breadth first search, we are going to use queue data structure. Queue data structure is just like real world queues in our grocery stores. First one in the queue will serve first. Hence, we call this is first in, first out data structure. Alright, so in this algorithm, first we enqueue or put our source vertex to queue. And then we have a while loop which will iterate until queue become empty. Now inside this while loop, we are dequeuing or getting the oldest element out of the queue in each iteration. Let's refer that dequeued vertex as u. And then we add all the unvisited vertices in the u vertex adjacency list to queue and mark those vertices as visited. And after this step, we are done with our u vertex. Hence, we are setting u vertex state as done. Now, you may already realize that to accomplish this algorithm, we need a variable in our vertex class to indicate whether it is in an unvisited state, visited state, or done state. For that, we are going to have a variable called color, which can take either white to indicate the unvisited vertex, or gray to indicate the visited vertex, or black to indicate that this vertex is in done state. Okay, now let's see an example run of this pseudocode. In this graph, we select vertex B as source vertex. And in the pseudocode before the while loop, we have enqueued our source vertex to queue and mark it as visited. Hence, the B vertex color is gray at the beginning. Now on the right side, you can see the state of queue. Currently, we have only B in our queue. In the first iteration, B will be dequeued from the queue or popped from the queue. And then we are going to add all the B vertex adjacency vertices to queue and mark those as visited. So B vertex here has two adjacent unvisited vertices, A and F. Here we will add A and F to queue and mark those as visited, and then finally we will set B vertex state to done state. So after first iteration, the state of our graph and queue will look something like this. Now note that at the end of the first iteration, vertex F and vertex A are in queue. Now which vertex go first to the queue depends on how it appears at the adjacency list for B. Here I have considered that F to go first. Now in the second iteration, we will pop another vertex from our queue. In this case, F will be that vertex. F vertex has 4 adjacent vertices. Out of those, B is already in done state. Hence, C, G, E vertices will be added to the queue and we will mark those vertices as visited by setting those vertices color to gray. And finally, we will set F vertex to done state by setting its color to black. So after second iteration, the state of our graph and queue will be look like this. Now for third iteration, dequeued vertex will be A. Now note that even though A vertex has 2 adjacent vertices, but none of them will be in unvisited state. Therefore, no vertex will be added to the queue in third iteration. So after third iteration, the state of our graph and queue will be look like this. In the fourth iteration, we will dequeue the vertex C. C vertex has unvisited adjacency vertex D. Hence, D vertex will be added to the queue and we will mark D vertex as visited by setting its color to gray. And then C vertex will be marked as done. So after fourth iteration, the state of our graph and queue will be look like this. In the fourth iteration, we will dequeue the vertex G. Now even though G vertex had 4 adjacency vertices, only one vertex, which is H vertex, will be the only unvisited vertex. Hence we will add H vertex to Q and mark it as visited. So after fifth iteration, our graph and Q look like this. Now after fifth iteration, all the vertices in our graph either in done state or in visited state. So the next iteration will only dequeue the queue one by one until our queue become empty. So finally our graph will look like this. Notice here that all the vertices in this graph is in done state.